When we watch an object move, we can ask more than one question. We can ask where it is now. We can ask how far it has gone. But we can also ask, what shape did its motion make through space? Imagine a small ball rolling across the floor, leaving a thin chalk trace behind it. If the ball rolls straight, the trace is a straight line. If the ball changes direction, the trace becomes a curved line. If the ball goes around in a circle, the trace is a circle. And if the ball comes back over part of the same route, the new trace can lie on top of the old trace. That imagined trace is called the trajectory. A trajectory is not a number. A trajectory is not the length of the trip. A trajectory is the geometric shape of the motion in space. It shows where the object has passed. For example, if a bird flies in an arc, its trajectory is a curved line through the air. If a train moves on a straight railway, its trajectory is a straight line. If the tip of a clock hand moves around the center of the clock, its trajectory is a circle. And if a planet moves around a star, its trajectory can be close to an ellipse. Now comes a very important distinction. The trajectory is the line followed by the object. The distance traveled is the length of that line. Think of a road drawn on a map. The drawing shows the shape of the road. The road may be straight, curved, circular, or broken into several pieces. That is like the trajectory. But when we say the road is 5 meters long, we are talking about a length. That is like distance traveled. So we should not say that a trajectory is 5 meters. The trajectory is not the number 5 meters. The trajectory is the trace. The distance traveled can be 5 meters, because distance traveled is the length of the trace. This also helps us name two basic kinds of motion. If the trajectory is a straight line, the motion is rectilinear motion. If the trajectory is a curved line, the motion is curvilinear motion. Those words sound formal, but the idea is simple: straight trajectory, straight line motion, curved trajectory, curved motion. This will become very important later. An object can move around a circle and return to its starting point. In that case, the trajectory is a circle. The distance traveled can be large, because the object went all the way around. But the displacement can be zero, because the final position is the same as the starting position. So we must keep these ideas separate. The trajectory tells the spatial story of the motion. It shows the places the object passed through. But the trajectory by itself does not tell us the total length as a number. For that, we need distance traveled. For now, remember this: trajectory is the shape of the motion. Distance traveled is the length of that shape. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.